Alrighty folks, good day again. We're talking about modeling fraction division, and this is going to be a kind of a long video, so you might want to grab something cold, a snack, and a couple pencils. Let's get started. We're talking about modeling fraction division. As I said, there are many different ways to show this. There's no one perfect way to present modeling fractions in terms of division. Or even multiplication for that matter. But there are a few accepted ways that are very easy to grasp, and that's kind of our goal as teachers, is to give you as many graspable topics and tricks as possible. So I'll try to do that in this video, and I'll try to be brief, but this might take a little longer than the normal video. So if you need to take a pause and come back to it later on, feel free to do that. I may try to pause in between as well, and I'm going to encourage you to do so as well. Make sure that your model, whatever your model type is, whatever you prefer to do, and whatever you see, matches with the accepted calculated answer. Okay? You'll know by the time you work through this that there is an accepted way to calculate a fraction division problem. I like to call it KFC. The information is located in another video. Please watch that video very closely and pay attention in class, as you'll learn a lot by doing those things. So make sure your answer matches or agrees with that calculated answer. And here we go. Pause if you need to, take breaks, and take notes. Here we go. When we are trying to use the model system that we typically use for multiplication, and that can be done, we're not looking for overlap though. We're not looking for where these things overlap. We're looking at just what's shaded actually, and we're just going to come up with a calculated answer based on that. I have 1/2 divided by 3/5, and if I were to calculate that, I would change my division sign to multiplication. Sorry, I would flip this, and I would keep this the same, and I would find an answer. Just for reference, the answer to this problem is 5/6. You'll need to know that. What I'm going to do is I'm going to shade this model based on the vertical shading here. For 1/2 of it needs to be shaded, and horizontally 3/5 of it need to be shaded. We have 1, 2, 3 out of 5. Here we have 1 out of 2. Okay, so we're shading things based on this position in the question. We are going to vertically shade 1/2. We're going to horizontally shade 3/5. So we've done that separately, and when you put it together, when you overlap them, you're going to see that, yeah, there is overlap. There are 3 items overlapped, or 3 boxes overlapped. But that doesn't matter. We're not looking for that. We're looking at just what's been shaded in. So when I put these together, and I see that there's almost like a grid system being created by that what I see here, 1, 2, 3, 4, 5 red sections, or red shaded sections, that's going to be my numerator for my answer. When I look at my horizontal shading, I have 1, 2, 3, 4, 5, 6. The number of horizontally shaded boxes is going to kind of turn into my denominator for my answer, 5/6. See? Isn't it weird how the calculated answer can agree with a picture answer that we can create? I want you to see that, and I want you to try that over the next couple of days, and I want you to ask questions in class, because we're going to attack this pretty aggressively. That's just one way of coming up with a decimal answer. Making a grid, making the horizontal and vertical shading, and then looking to see what actually is created with those grid lines. Horizontal and vertical shading. Take breaks, guys. Take a breather if you need to. Take a pause, and we're going to move on to the next little item that we can attack here, and that's using repeated subtraction. This doesn't work that often for every question that we deal with, but I think it works well when we have the same denominator, and I like to use it here just to see if it is possible. I think it will be, and I'm going to do a little bit of work on the screen, so I hope you don't mind that. But in repeated subtraction, that really is the basis for division anyway, so it's allowable. It's okay to do. Let me get a different color ink here. Red, that works. Alrighty. So if I'm going to divide 7/8 divided by 1/8, I'm basically thinking to myself, how many 1/8 will fit into 7/8? And you might be able to figure that answer out in your head, and we can say it. The answer would be 7. 7 1/8 little measures fit into 7/8. But I need to support my answer still. I need to either calculate it as a real problem, or I can use what looks like a number line to figure that out. And I'm going to do that right now. If I start at 7/8, if I were to actually plot 7/8 on a number line, I can subtract 1/8 off that. And if I subtract 1/8 off that, I end up here at 6/8. This is 6/8. If I were to subtract 1/8 again, I would be at 5/8. If I were to subtract again, I think you can figure out where we would be. If I were to keep going until I get to 0, until I have no value left, and I count up the number of moves it takes, the number of times I am subtracting, that's going to tell me my answer. And I can just do a simple count. 1, 2, 3, 4, 5, 6, 7 moves. It takes me 7 steps or 7 moves to get back to 0 from 7/8 by subtracting 1/8 each time. That's my answer. For this type of situation, that would be my answer. Now, how do I know that my answer is correct? One, I think that some of us can calculate that in our head, so we're using prior knowledge. We are using this as a guide as well, this number line, but we can also use the KFC method that we've talked about in class. Keep it, flip it, change it. I'm going to keep the first fraction the same, I'm going to flip the second fraction, and I'm going to change the division sign to multiplication. By doing that, I can just do a simple multiplication problem. I come up with 56 over 8. 7 times 8, 8 times 1, and 56 divided by 8 is 7. So I have confirmed my answer once again. Again, this is a lot of stuff, so don't be afraid to take a rest, take some notes, write down some questions, and where things might be difficult for you to understand. Before I move on from this board, I want to remind you that this doesn't work for every single example. This works for examples that have the same denominator. It may work for things that have similar denominators like 4 and 8, where you can easily convert one of them to a common denominator. But for the most part, this won't be very commonly used. But it is another example of how division can be done with models. Last one, hopefully the last one, is what I like to call a bar model. And this is another type of drawing picture to figure out a quotient or to figure out which equation best fits the situation. The question says, which equation is being shown? So we have some multiple choice answers, and I'll reveal those in a second if you can't see them. But we're given a picture. We're given a picture of what looks like 1 out of 3 shaded, and we have over here, it looks like 1 out of 1, 2, 3, 4, 5, 6 shaded. So it looks like we have 1/3 and 1/6 being shaded there. And if we look at the second step, it looks like we're taking the 1/3 and we're trying to figure out how many of these fit into the 1/3. It appears as though there are 2 of these that fit into the 1/3. Now my question to you is, which one of these answer sets best matches that? And I'll give you a second to answer that. 1, maybe 2, maybe 3. Which one do you think it is? If you answered A, I would have to say you're close. If you said B, I would have to say that you're correct. If you said C or D, you may not be looking at the shaded values, you may be looking at the unshaded blocks. The answer is going to be B, because we're seeing modeled 1/3, we're seeing modeled 1/6, and it appears, as I said before, that we're trying to figure out how many of these 1/6 fit into the 1/3, and it looks like 2 fit into it. So if 2 of these fit into it, we can say that the answer should be, and they call it a quotient on tests and quizzes and other assignments, but it really is an equation basically. 1/3 divided by 1/6 equals 2, because there are 2 of these that fit into that 1/3. This is the one that I find that students have most difficult time with. I want you to look at each of these carefully, and and look at what's being modeled. Look at what's being combined here, and because this ultimately is going to tell us what the answer is. It's something that students sometimes have a hard time with. We're going to attack that very aggressively in class. this has been a very long video. So don't be afraid to rewind it, watch it again, take some notes, ask questions, and don't be afraid to say something in class, because the only silly question is the question not asked. Time for a break.